So let's do a couple of examples. So let's see. I've got an object at rest. And the static coefficient of this object and the surface, you can look them up. See, these static coefficients, they don't depend on the weight. You can just look them up. Or the speed. The static coefficient, let's say, is 0.6. And let's say the kinetic coefficient, which would be lower, is 0.4. And the weight of the object is 8 pounds. I want to know what force will get this thing moving. Now, let's check it out here. Static force of friction. Oh, I'm sorry. What force of friction? It's at rest, so we've got to use the static. We won't use the kinetic. So the static force of friction is mu sub s, the static coefficient, times the normal force. Now the normal force is just this weight of 8 pounds. So this is 0.6, no units, times 8 pounds, which is 4.8 pounds of force. It takes 4.8 pounds of force to move this thing. Keep in mind, if I push, it takes 4.8 pounds to move it. If I push with 1 pound, it's not going to move, and it's going to fight back with 1 pound, because it's not going to move, right? If I push with 2 pounds, it's not going to move. It's going to be exerting 2 pounds of frictional force on me. It's going to keep exerting the same force that I'm pushing at it, because if there's no net acceleration, there's no net force. They cancel out until I hit 4.8 pounds. And then when I hit 4.8 pounds, that's going to be enough, just a little over, to move it. And things will change. So static. Let me do a kinetic, and I'll use metric units. So you got a good picture of that. So you can pause it if you need it. All right, now I'll do a metric. Object slides at constant speed. Now the reason I'm having it slide at constant speed is if I'm pushing in this direction, I'm going to apply a force here, and friction's going to fight it here. But the net force is, well, force is mass times acceleration. The net force is the mass times the net acceleration. If there's no acceleration, it's moving at constant speed, that means it's not accelerating. So if I'm moving at constant speed, that means I'm just compensating for the force of friction. There's no net force. That means that the applied force is equal to and opposite the frictional force, canceling each other out. I'm moving, but I'm not accelerating. If you're driving in your car at 60 miles an hour, you got your foot down, I mean, on the throttle, you're moving, you're applying energy, you're applying a force, but drag and mechanical friction are battling it out with it, and so there's no net force. So let's see. Let's say the static coefficient here is same kind of thing. Let's say it's 0.6, and the kinetic coefficient is 0.4, and let's say this thing has a mass of 7 kilograms. Now, I want to know, what's the applied force? Well, since it's moving at constant speed, the applied force must be just balancing the frictional force. There's speed but no acceleration. So the applied force, in this case, is equal to the frictional force, and that's the kinetic because it's sliding. The kinetic force of friction, which is mu sub k, times the normal force. I don't have the normal force, but I've got the mass. So that's mu sub k, right there, times mass times gravity. Because the weight, mass times gravity, is equal to the normal force. I could calculate it separately if I wish to. So this is 0.4 times 7 kilograms times the acceleration of gravity, which is 9.8 meters per second squared, which is some honking number. Oh, calculator. Oh, look at that. Gotta have these when your name is Sandy. Let's see. 7 times 9.8 times. And just looking at this, you'd say, okay, 7 times 10, 70 times 0.4, 70 times 4 is 28 or so. It says 27.4. And the units are kilogram meters per second squared. That's newtons. So the frictional force is equal to the applied force, and it's 2.74 newtons. So that's how you look at sliding. And sorry, beans for breakfast. So you got sliding and kinetic friction. You got English and metric units. Make sure you understand it. You might want to do a few extra of those. We should talk about drag resistance.